For the unexpected findings, usually for phospholipids, for the phospholipids, especially phosphatidylcholine, since the product is basically egg-based or egg yolk-based. So there's no secret to that. So it's mostly composed of PC or phosphatidylcholines. Sometimes we're only expecting like maybe 2 or 3 phosphatidylcholine species, but apparently we have a lot more. For instance, if you have the poster, for instance, as a reference, there is one analyte that is annotated as PC384 or 364, if I'm not mistaken, that has 4 peaks. And usually we just expect it to have a 2, maybe co-eluting peaks because we're only expecting 2 species. But here we found 4, for instance. And those 4, they are actually corresponding to several possible combinations of the phospholipid that has the condensed formula, for instance. Because to everyone that is not familiar with the phospholipid, so a phospholipid is a lipid with a polar group, a polar phosphate group, and 2 tails, and those 2 tails are mostly fatty acids. And with those combination of fatty acids, because there's a huge range of fatty acids to choose from, so therefore there are a lot of possible combinations that constitute the condensed formula. And therefore, in our findings, we found out that the 2 prominent ones, for instance, for this particular condensed formula, apparently there is 4 that is actually detectable and quantifiable. So these are just one of the examples of our unexpected findings. We also found out that the lysophosphatidylcholine or the LPCs, for instance, their increased ratio in the product has actually an effect towards its stability, for instance. So those things that we're looking more closely into. So those are the unexpected findings from our current work that we wanted to explore more.